Hello, Chapter 3, Section 2, a nice little trig problem. What makes this thing hard is you have to figure out how you're going to draw this from what perspective. Because when I first see this, it says an airplane undergoes two displacements. I'm thinking of an airplane, flying along across like that, and that's not how you want to look at that. You don't want to look at it from a squirrel's eye point of view. You want to look at it from a like a satellite point of view. So what we're going to do is draw an XY axis like this to get our angles right. So it says an airplane undergoes two displacements. The first is 75 kilometers, 30 degrees west of north. So let's make this here the starting place. So this is where that plane starts, and we'll get our first vector. And it says that it's going to go 75 kilometers, 30 degrees west of north. Let's label this north, south, east, and west. And we are going to go west of north. Okay, so here's north, here's west. So your vector is going to go, here's straight north, here's about 30 degrees west of north. Okay? So it's going this way. It's going to the west from the north. And I'm going to make that right there represent 75 kilometers. So I'm going to have the length of that vector be 75. Okay. And we should probably fill in, that would be 30 degrees right there. I probably should have stretched that out a little bit more, but that's okay. I can zoom in if I need to. Now it undergoes another turn that goes 155 kilometers, 60 degrees east of north from this point right here. So from that point, it's going to do another turn. So what I need to do is overlay another XY axis right here. So I'm going to make another XY axis right here. There it is. And this thing is going to go, my line's all right, 60 degrees east of north. Okay, so here's east and here's north. So here's straight north, so it's going to go about 60 degrees east of north, something like that. Except it's going to be a little bit longer. So I'll stretch that out just a little bit longer. Now the reason why is because this is 155 kilometers, which is over twice as long as that. And the angle 60 would be right here. 60. Okay. So remember, this is 30. This is 60. And what we have to find is, get a nice color like white. We have to, yikes. We have to find the length of that line right there. Okay? All right. So we have a right triangle somewhere in here. We have lots of right triangles. This problem here is kind of unique because if I zoom in here, okay, right at this point, and I've just zoomed in. This 60 and this 30, if we break this down, let's see, this is going to be, this pink line here. So that, do that. This is how long? Well, if that's 60, and I know that this is a right angle right here, that has to be 30. Let me make that a little bit neater so you can reference this in the future if you need to go back and watch this. So if that's 30, and we know that if this is 30, then that is an alternate interior angle, that has to be 30. So let me make that color match. So that's 30, which makes this angle equal to what? Well, so far we have supplementary angles right here, right? That's 180. So this has to be 60. This is very complicated. But we can see that this is a right angle and that's a right angle. And they're both equal to 90. But if we put this green side, this angle, and that angle together, do you see that it equals 90 degrees? So this is a 90-degree angle. And this green line here, by the way, was 155. So what we need to do is find the length of the white line, and since this is a right angle here, this becomes pretty trivial. So this is nothing more than 75 squared plus 155 squared equals c squared, and I'll be right back with that answer. Okay, just making sure I'm recording. Yes, we're good. Okay, so we've done this, and what this simplifies to here for c squared is 29,650, which, if we square root that, it's about 172.2. So this line right here is 172.2 kilometers. But this, we need a magnitude and direction. So what we need to do is reference, we need to find an angle somewhere here. Let's see, how would we do that? Well, if we have the three sides, we have this side, we have this side, 75, and 172.2. If I want to find, say, this angle here, well, that's nothing more. If I draw a little sub-triangle, it'll probably be easier to see. Okay, if we draw a little triangle representing that mess, this would be 155, this would be 75, and this is 172.2. If I want to find that angle right there, I could just do tangent of that angle theta, which would be 150. Let me zoom back out just a little bit so I can see what I'm doing. 155 over 75. That would be opposite over adjacent from there. And that is, let's see, second tangent 155 divided by 75 is 64.2. Okay, so this angle, this whole angle here, is that green angle, is 64.2. But what they're going to do in the book is not give you that angle, because that's an angle that you can't compare to a compass. See, this is your, let me find the brightest color I have. This is north right here. Okay, that's north, and this is east. So what you want is this angle. Okay, you want this angle here, because this whole thing we just saw was 64.2. So this side here would be 30, because that part right there is 30. So it basically looks like this. You have an angle here that's 30, and the whole thing is 64.2. So this side is the leftover piece, and that's 34.2 degrees. So this is 34.2. 34.2. And this is our mystery angle that we need, and that would be 34.2 degrees east of north. Final answer. So your final answer would be phrased like this: 172.2 kilometers, 34.2 degrees east of north. Final answer. What a problem. Have a good one.